Welcome to Macmo Academy. Dear students, in this video, we will understand properties of complex numbers and some topics or things related to the operations on complex numbers. So in our previous video, we have understood that how to apply basic operations on complex numbers. In this one, we will see the properties of complex numbers. So first one is commutative property. Commutative property. So in commutative property of addition, as you already know, commutative property in matrices you have done, in sets you have done in grade 9, commutative property, it is changing of order. That for example, if there are two complex numbers and they are adding, but if you will change the order of it, will they be equal or not? So commutative property is applicable on complex numbers in addition. But what about multiplication? So it is also applicable in multiplication as well. When two complex numbers are multiplied, so if you remember in the matrices, commutative property of multiplication is not applicable generally, but in complex numbers it is applicable if you will change the order, means if you will multiply the first complex number with the second or the second with the first, it will not change your answer. So let's take an example first. We have two complex numbers. Let's say first one is 2 plus iota and second one is 3 plus 2 iota. So when you will add them, let's apply the commutative property of addition. So z1 plus z2. So z1 is 2 plus iota and z2 is 3 plus 2 iota. So we have already discussed that how to do the addition of complex numbers. Real part will be added with the real part and imaginary part will be added with the imaginary part. So it is 5 plus 3 iota. Now let's change the order of it. Let's do z2 plus z1. So you will get 3 plus 2 iota plus 2 plus iota. So over here you will be able to do 3 plus 2 5 and 2 plus 1 3 iota. So you can see over here that commutative property of addition is proved over here. Now let's take the same complex numbers and let's check the commutative property of multiplication. So in multiplication, we have already discussed in our previous video that when we do multiplication of the complex numbers, it is also very simple. For example, if we are finding z1 multiplied by z2, so we use the concept of the expansion. 2 multiplied by 3 will be 6. Then let's do it directly because we already know how to multiply. Then 2 to the 4 iota and 3 ones are 3 iota. So together it will be 7 iota. But when you multiply iota with iota, you know that iota square is equals to minus 1. So you will get 2 ones are 2 iota square and then there is minus 1. So you will get minus 2. Right? Now 6 minus 2 is 4. So you will get 4 plus 7 iota. So this is the answer of z1, z2. Now let's change the order. z2 multiplied by z1. So now you will write 3 plus 2 iota first and 2 plus iota will come later. So you can see over here it will not change the sign. 3 to the 6 again. And then again when you multiply 3 iota and then you will multiply this with this, 3 to the 6 and then 3 iota and then 2 to the 4 iota and then again same thing, 2 iota square, it will be minus 2, so you will get the same answer. 4 plus 6 minus 2, 4. 4 plus 7 iota. So this is how we can say that the commutative property of addition as well as multiplication is applicable on complex numbers. Now let's see the second property. Alright students, so after commutative property, we have associative property of addition and multiplication. I will not solve the question related to it, because if you will look at the property, you need to remember the property that it's just about addition. So you already know how to do the addition. So if there are three complex numbers and you are proving associative property of addition, so you will solve the first two complex numbers with addition, and then the answer of those two will be added with the third one. Same over here. The second and third complex number will be added, and then you will add the answer of them with the first one. In the multiplication also it is applicable, that first multiply the two complex numbers and their answer will be multiplied with the third one, and same way on the right side. You must get left hand side equals to right hand side. Now if we talk about distributive property, so we have it over addition and we have it over subtraction. So it's already, you can understand that what, when you will open it, what will you get. But if you want to prove it with the property in the question, it will come as to prove it. Then what you need to do, you need to multiply. On the left hand side you need to first add them, and then you need to multiply it with z1. So already you know that how to do addition, how to do subtraction. In subtraction also, as we have already discussed, that real part will be subtracted with the real part and the imaginary part will be subtracted with the imaginary part. But here you need to understand one very important thing, that when you are doing subtraction, that use the bracket and minus sign and then bracket, so that it will change the sign of the z3 or whatever this complex number will be in the question. Similarly over here, when you will do it, so you will first multiply z1 with z2 and z1 with z3. Now when you will do subtraction, so for example, let's say if you are getting z1 and z2 as 4 plus 3 iota, and z1 multiplied with z3 as 5 plus 2 iota. So when you will do subtraction, be careful with it. You will always use the bracket so that the sign will be changed, because students do this mistake over here, that they just write the minus sign with the first term and ignoring the second term. So that's not the case. You need to open it with the minus sign, so sign of both the terms inside real part as well as imaginary part will be changed. So this is how associative and distributive property are applicable on the complex numbers. Now we will see some properties related to conjugate of a complex number and modulus of a complex number. So I'm not solving any question related to it, because in these properties addition, subtraction and multiplication is happening, and we have already discussed this in our previous video of basic operations of complex numbers. So now let's see properties of conjugate and modulus of a complex number. Now as you already know about conjugate of a complex number, conjugate of a complex number means changing the sign of the imaginary part of the complex number. We have already discussed it. Now there are some very important properties related to conjugate of a complex number. First property is, if you will do the, so how will you represent the conjugate? A bar on the complex number. So if you will, and if you will think smartly, you will easily understand it. If we are taking the conjugate of a complex number and we will take again the conjugate of that conjugate, so what will you get? You will get the original complex number again. For example, if you have a complex number 4 minus 3 iota, it is your original number, complex number, and you are taking its conjugate, so it will be 4 plus 3 iota. And then if you will take the again the conjugate of this, which we call double conjugate, you will get 4 minus 3 iota again. So it is similar to this. This is one of the property. Second property is, if you will do the conjugate of the sum of two complex numbers, conjugate of the sum of two complex numbers, it will always be equal to the individual sums of the conjugates. And these properties are already proved. So when you will do it, it is not like this that you need to check it. The question will be of prove that, prove this property, etc. So over here it is written that if you have two complex numbers and you are first adding them and then you are finding its conjugate, So that will be equal to, if you are let's do it. For example, if you have one complex number, this one, z1 is equals to 4 minus 3 iota, and you have another complex number as minus 2 minus 4 iota. Now let's apply this. So we will do 7, first of all add them. So 4 minus 2, it will be 2. I'm doing it a little bit directly. Minus 3 minus 4 minus 7 iota. So this is the sum of it. Now if I will do the conjugate of it, it will be 2 plus 7 iota. So this is the left hand side. Now if I will do the conjugate of this one, it will be 4 plus 3 iota, and the conjugate of z2 will be minus 2 plus 4 iota. Now again do the sum of it. So 4 minus 2, it will come 2. 3 plus 4, it will come 7 iota. So you can see over here, it is proved. It is coming equal to this. So this is what this property tells us. Third property is for the subtraction, the same property, but for subtraction. That if you are doing the subtraction of two complex numbers and then you are taking its conjugate, so it will be equal to the subtraction of them or the individual conjugates subtraction. So you can prove by using it these same complex numbers by yourself as well. The fourth property is related to multiplication, that if you are multiplying two complex number and then you are finding its conjugate, so that will be equal to the product of the individual conjugates of those complex numbers, like this. So these are few important properties related to it. Similarly, for the division, if you are doing the division, and we have already done the division of the complex numbers in our previous video, so division is not very much simple. You need to multiply and divide your fraction or numerator and denominator by the conjugate of the complex number. So you can watch that video for this understanding. So if you will do the division first and then you will find the conjugate of the answer, that will be equal to the division of the individual conjugates, like this. All right, I am showing you proof of this property right now for the division conjugate, so that your division concept will also be revised and you will get to understand that how this property will be proved. So let's take two complex numbers. Z1 is equals to 3 plus 2 iota, and Z2 is equals to 4 minus 5 iota, right? Now first of all, left hand side says कि first divide it and then find a conjugate. So first divide it means 3 plus 2 iota divided by 4 minus 5 iota. For division, you need to multiply this whole fraction by the conjugate of this denominator. So it will be 4 plus 5 iota and 4 plus 5 iota. For better understanding, you can watch our video of basic operations on complex number to understand it. So now it will come 3 4s are 12, numerator multiply numerator, and 3 5s are 15 iota, 2 4s are 8 iota, and 2 5s are 10 iota square, so it will come minus 10. And in the denominator, you can write directly a minus b, a plus b, so it will be 4 square minus 5 iota square. So you will get 12 minus 10, 2 plus 23 iota. And in the denominator, you will get 16, and then iota square will be minus 1, and 5 square is 25, so it will be minus minus plus 25. So you will get left hand side as 2 plus 23 iota upon 25 plus 16, 41. Now this is the left hand side, z1 upon z2 and then its conjugate. Oh, I have not done the conjugate, wait. I have just done the division. Now after division, you need to write it like this, 2 upon 41 plus 23 upon 41 iota. This is how finally you will write the answer in the division of complex number. Now conjugate of this means that 2 upon 41 will remain as it is, and you will change the sign of the imaginary part. So this is your left hand side of this particular question. I hope you have understood that how have we done this. Now For the right hand side, it is written first find the conjugate. So let's find the conjugate of this. It will be 3 minus 2 iota. And then find the conjugate of it. It will be 4 plus 5 iota. Now let's do the division of it. So when you will do the division of 3 minus 2 iota with 4 plus 5 iota, it will be the same process, that you will multiply and divide your whole fraction by 4 minus 5 iota, means conjugate of this. So when you will do it, what will you get? 3 4s are 12 minus 15 iota minus 8 iota, and 2 5s are 10 minus minus plus 10 iota square, so it will be minus 10 again. And in the denominator again you will get 16. 4 square is 16, and then 5 square is 25, so it will be plus 25. So finally you will get 12 minus 10. 12 minus 10 is 2, and minus 15 and minus 18 is minus 23, so it will come 2 minus 23 iota upon 41. Break the LCM, you will get the same answer, 2 upon 41 minus 23 upon 41 iota. So this is how we can prove our properties. So the things are very basic. If you already know how to find a conjugate, if you already know how to addition, subtraction, multiplication and division, you can easily prove the properties of the complex number. So these properties are related to the conjugate of a complex number. Now we will understand that how to find the modulus of a complex number and what are its properties. So what is mean by modulus of a complex number? You already have done in grade 9 modulus or the absolute value. So it is very much similar to that. For example, if you have a complex number z, so modulus means like you have done absolute value, and then it will be equal to under root a square plus b square, where a and b are the real and imaginary parts of the complex number. For example, if you have a complex number 3 plus 4 iota. So if you want to find the conjugate of it, sorry, complex modulus or absolute value of it, you will find the square of the first term. First term means the real part, and you will put the same sign. For example, if it is written minus 3 over here, you will write minus 3 over here. And you know that for the negative number square, you will get the answer positive. So that's why we have a square over here, and same for this. So you will get 3 3s are 9, 4 4s are 16, and finally your modulus of this complex number will be 16 plus 9 under root 25, that will be 5. So this is how we find the absolute value or modulus of a complex number. Let's take one more example. For example, if you have a complex number z is equals to 15 5 minus 3 iota. Now if you have this particular complex number similar way, 5 square. Now some students do this mistake that they think that if it is written minus in between, you will write minus over here. No, in the formula it is written plus, you will also write plus. Where will this minus will be written? With over here, because it is the value of b, so you will put it as it is. So 25 minus 3 square will be 9, so it is under root 34. So by using simple calculator, you can easily find the value of the square root 34. It will be something 5.8 or like that. So this is how we find the modulus of a complex number. Now there are some properties related to it, and those properties are also very easy, like the properties of the conjugate. So now let's see what are its properties. First property says that when you will find the modulus of a complex number, it will be equal to the modulus of its conjugate. Means if you have a complex number 3 plus 2 iota and you are finding its modulus, so you will get 3 3s are 9, 2 2s are 4 under root 13. And if you will find the modulus of its conjugate will be minus 3 minus 2 iota. So you are doing the square now, that's why it will not change the sign. So again 3 square it will be 9, and minus 2 square is also 4. So that's why it is not changing and they are equal. This is the reason. So if you will connect the reasons, you will easily remember it and understand it. Property 2 says that whenever you will do the multiplication of two complex numbers and then you will find its modulus. For example, you have two complex number and you are multiplying it and then you are finding its modulus. So it will be always equal to the individual modulus and its product. So you have two complex number, you multiplied it and then you calculated its modulus, or you have two complex numbers, you first find the modulus of the first complex number and then the second and then you multiply it, so they will always come equal to each other. And same goes for the division. If you have two complex number and you are dividing it and then you are finding its modulus, so it will be equal to the individual modulus of these two complex numbers. Finally, the third property you have done, and then the fourth property says if you will find the square of the modulus like this. First you calculated the modulus and then you are finding the square, so it will always be equal to the product of modulus with its conjugate, right? So let's prove this one. Let's prove this particular property. We have a complex number, let's say minus 6 plus 5 iota. So let's find the modulus of it. So modulus of it will be 6 square or minus 6 square is 36 plus 25. So it will come 36 plus 25, 46, 56 under root 61. And then find its square. So the answer will come 61. Right? Because the square and root will cancel with each other. Now, what are they saying? You need to multiply this complex number with its conjugate. So you will do minus 6 plus 5 iota. And you will multiply it with minus 6 minus 5 iota. Remember, in conjugate you will just change the sign of the imaginary part, not the real part. So what will you get? Minus 6 multiplied by minus 6, 36. Minus 6 multiplied by minus 5 iota plus 30 iota, right? And then multiply this again, it will come plus minus minus 30 iota, and it will come 5 5s are minus 25 iota square, but there is minus and iota square is also minus, it will come plus 25. This will cancel with each other, so what will you get? 36 plus 25 is equals to 61. So this is how we prove the identity. So if we don't know about multiplication correctly, if we don't know about conjugate, what is meant by modulus, how to divide, how to multiply, how to add, we will not be able to apply the properties correctly. So this is it from this video. If you did not understand anything, you can ask us, and in our next video of this series we will discuss the additive inverse and multiplicative inverse of complex number. Thank you for watching the video. If you like the video, don't forget to subscribe our channel.